and A3 T61 AO4, carrying on with the theme of psychrometrics. And this one is asking us, what is the enthalpy of the air leaving the coil? Let's go back to our plot that we had drawn in a previous question, which is right here. And we can actually clean this up a bit with the eraser. We're going to take out a whole bunch of arrows. That can come out. These specific volume lines can come out. All these little arrows here. And let's just look again just at our process line, which is position 1 to position 2. And we can put a little arrow on it like this so that we know the air enters the coil at 1 and its conditions changes as it moves through the coil and leaves at position 2. Now in this question, if we want to know the enthalpy of the air leaving the coil, because we have a data point of the conditions of the air right here at point number 2, we can easily interpret from our psychrometric chart the enthalpy of the air. So where is enthalpy found? Well, once again, look very closely. Enthalpy lines are right here, right? On this scale right here, which moves from, say, 15 all the way up to 35 in the areas that I'm highlighting anyways. So we're going to easily be able to interpret enthalpy from our position number 2. We're only looking at this specific area here. And I'm going to draw a line from point number 2 on my actual curve, and I'm going to try to keep it as parallel as possible to my enthalpy lines, which are kind of running diagonally from top left to bottom right. So here we go. Oop, sorry, I'll use red. And you know what? Let's just draw it straight up like that. There we go. Okay. So if our air at position number 2 represents the air leaving the coil, then we know through interpolation of that point on the psychrometric chart that it leaves the coil somewhere between 20 BTUs per pound of dry air and 25. And if I was to look really closely, I would say that this is 21, 22, 23, 24, 25. So I'm pretty close to 23. In this case, I look back at my answer choices and see which one's closest to 23. It really looks to me like there's only one viable option, and the viable option is going to be A, 22.7. I mean, we're interpolating data. You know, it looks like 23, but if it says 22.7 in the question and all the other options are way off, then you choose 22.7. So I'm saying this is the correct answer based on what I see, because 27.6, 28.1, and 30.2 are way too far away from what I'm graphing. And what I graphed, once again, is right here. Clean that up. All right, I graphed it right here. I took that diagonal line and it intersects my enthalpy scale somewhere between 20 and 25, and it looks like 23, or in our case, specifically 22.7 BTUs per pound. And that piece of information will be used in subsequent questions.